All right, Mr. Ahmed here for Quadratic Applications. Goal for today is to take some word problems and we're going to solve some real-world application type problems with quadratics. And a couple key things we have to identify here just based off a quadratic function. In terms of time and height, this is the most common real-world application of a quadratic. And that is really used when something is thrown, launched, or somehow or another, it could just be dropped from the air. If it's just dropped, it's going to go straight down, but we're throwing it forward with some force. And then that object could go up, and then it will come down. So the most common example I always come up with is like a punt of a football. So if a punter punts the football, the ball goes up, hits a certain point, and then comes down. This makes that nice parabolic type shape. And we can use it to model some specific things. So, a couple key details that we have. The y-intercept. When I have the y-intercept, that is when the time is at 0. So this y-intercept is how far or how high off the ground did the object start at. And the reason why that's the case is because t is equal to 0. We cannot have negative time. So this 0 over here on the left, if we end up having one of these, this one's going to get thrown out. It's extraneous because I cannot have negative time. Time can only be positive. So this 0, if it's negative, will not be a solution. At the vertex is going to be the highest point of the graph. And this is just a model of parabolic type function with negative 16t squared plus 16t plus 121. The x value is the object at its maximum height. And for us to calculate it, that is how we calculated that axis of symmetry. So the time when it's at its maximum height would equal negative b over 2a. That's that x value of the vertex. In this case, our x value is time. So our function is time. And h, our y value, is the height. So on our y-axis is how high the object is. And the x-axis, going left to right, that is the amount of time that has passed. So left to right is time, up and down is the height. The y value of the vertex, that's the absolute maximum height that it got up to. So this vertex, the x value is the time that it's at the max height. And the y value is the max height, okay? So we might ask ourselves, how high is the object after blank seconds? That would be t seconds. So we'd plug that in, and then we would be able to figure out its height. And that could be at any point on the graph over a course of time. At the bottom, when it hits the ground again, the height is at 0, okay? And that would also tell us how long that it was in the air. All right, so these are the roots of the function. And like we said, we'll throw out the negative root because there cannot be negative time. So that's a brief little summary of what we got going on. So we are going to use a graph in order to determine some specific values. And what we got going on here is we're supposed to use the graph at the right. It shows the height h in feet of a small rocket. So we launched a rocket into the air, t seconds after it's launched. The path of the rocket is given by the parabolic function, negative 16t squared plus 128t. So there's no c value for this, hence it's starting on the ground. If there's a c value, it would start at a specific height. So the first question says, how long is the rocket in the air? So for me to determine how long the rocket's in the air, that has to go from here all the way to here, which would be 8 seconds. Was in the air for 8 seconds. 0.5, 1, 1.5, 2, etc., all the way to 8. What is the greatest height that the rocket reaches? So the highest height, we're looking at the graph. Here it's at 15 feet, 195, and it appears as if the highest height's right about 260, something like that, 265. So we're going to approximate that and call it 260. Somewhere in there. We aren't exactly sure. It's not an exact point. About how high is the rocket after 1 second? So after 1 second, how high is the rocket? Appears to be right at about 90 feet. 1 second, up 90 feet. After 2 seconds, how high is the rocket? 2 seconds, it appears to be right at about 190, 192, something like that. I'm gonna go with 190. And it appears to still be going up. At this point, it stops going up and starts coming down. So at 2 seconds, it's still going up. Okay, still going up. All right. And after 6 seconds, we're going to look what happened at 6 seconds. So at 6 seconds, it appears to be at right at about 190 feet again, because it went up to like 260. Then it's coming back down. So at 6 seconds, it was at about 190 feet. And is it going up or down? Well, at 6 seconds, it has started its downward path. It's heading back to the ground. Okay. Do you think the rocket is traveling faster from 0 to 1 seconds or from 3 to 4? So from 0 to 1 or from 3 to 4. So when I look at 0 to 1, I see like it's going pretty fast. It gained quite a bit. Then from 3 until 4, it seems to have slowed down. So I would say that it was steeper. So it's faster from 0 to 1. And the reason I'm going to explain it is because it is steeper. And we could also calculate that, and we could see from 0 to 1, it went from 0 to 90 feet. So that's 90 feet in 1 second. And then from 3 to 4, it only went from 240 to 260. So it obviously went further in 0 to 1, so it had to be going faster. Okay? And using the exact equation, find the exact value of the height of the rocket at 2 seconds. So for me to find the exact value, I'd have to actually plug 2 into the original equation. The original equation is negative 16t squared plus 128t. And we have to find h. So we have to plug 2 in for t. So we'd have negative 16 parentheses 2 squared plus 128 times 2. So I'm going to use my calculator for that. And let's see, we got negative 16 times 2 squared plus 128 times 2. I got 192 feet. So that's the exact one. And that's the end of our first question. So we can use this graph to determine quite a bit of information. On next one, it says we have a ball that is thrown into the air. The path of the ball is represented by the equation t squared, or sorry, negative t squared plus 8t. We're going to graph the equation over the interval from 0 to 8 on the accompanying graph. So the first thing I need to do is make a chart. Okay, so I need to make a chart here with our time and our height, and I have to go from 0 to 8. So I'm going to make 2 charts. So plugging in 0, our equation is negative t squared plus 8t. 0 goes in and I get 0. So it's starting on the ground. So I'm going to plot the point. 0, 0, and this is the time, and this is the height. Okay, all right. Next one, I have to put in 1. So negative parentheses 1 squared, using my calculator, plus 8 parentheses 1, and I am at 7. So I have the point 1, 7. Then I got to plug in 2. And I'm at 12. Now I plug in 3. and I got 15. Okay, now that hopefully you get the idea of where we're at there. I'm gonna keep filling in the rest. 4, I got 16. At 5, it's at 15. At 6 seconds, we're at 12. At 7 seconds, we're at 7. And at 8, we're at 0. So I kind of did those in advance. Now I just have to plot all my points. So 0, 0. Then I have the point 1, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to 16. I only have to go over to 8 here. All right, kind of keep having to fill in my points. At 2, I'm at 12. So over 2, up 12. Over 3, up 15. Over 4, we're at 16. 5, we're here. At 12, at 15, sorry. At 6, we're at 12. And at 7, we were at 7. And 8, we're back down to 0. So here is my nice, gentle, U-shaped parabola. And what is the maximum height of the ball? It appears the maximum height was 16 feet. And how long is the ball? Above 7 meters. So from here to here, it's above 7 meters. So that's 1, 2, 3, 4, 5, 6 seconds. Okay, above 7 from here all the way to here. And that's all we got there for that example. And on to the next page. And we're going to go over this. So, with our word problem, some things to remember. T is the time. It represents the x-axis. And h is the height. It represents the y-axis. When the object hits the ground or the water, the height is at 0. Okay? So we have to answer some questions here just using the formula. So it says, after t seconds, a ball is tossed in the air from ground level, reaches the height of h feet given by the equation 144t minus 16t squared. And it says, what is the height of the ball after 3 seconds? So h is equal to 144t minus 16t squared. We have to put 3 in for the time to figure out the height. So h equals 144 times 3 minus 16 times 3 squared. And you would use your calculator for that. And we would come up with a height of 288 feet. And you would just have to plug that in using your calculator. It says, what is the maximum height the ball will reach? So the maximum height, that is the vertex. So for us to calculate the vertex, we have to find the x value first. H is equal to, t is equal to negative b over 2a. That's the time that it's at. So in our example, I need to label a, b, and c. So if I put this into standard form, h is equal to negative 16t squared. I'm swapping the order. Plus 144t. A is equal to negative 16, and B is equal to 144, and in this case, C is equal to 0. So when I plug this in to the vertex, negative B, so I'd have negative 144 over 2 times negative 16. And when I calculate my vertex, I get 4.5 seconds. So for us to figure out the maximum height, we still have to plug that back into the original equation to find out how high it was. So the height, h, I'm going to grab a different color to find the h value. We use black for that. So the height of the ball is equal to negative 16 times 4.5 squared plus 144 times 4.5. So we'd use our calculator to calculate that. and we would get 324 feet for the maximum height. Okay, so we calculated the vertex. Vertex at 4.5, 324. And our next question, part C, states, find the number of seconds the ball is in the air when it reaches a height of 224 feet. Actually, I'm going to put this here, max height is. Okay, so find the number of seconds the ball is in the air when it reaches a height of 224 feet. So we had a ball launched here, and it's at 0 feet on the ground, and we want to figure out when it's at 224 feet because we know that the top was 324. So it's going to be at 224 feet 2 times. So in order for us to calculate that, we are going to set up the equation with h equals negative 16t squared plus 144t, and our height is 224. We want to know what the time was for that. So 224 is equal to negative 16t squared plus 144t. For us to solve this, we have to set the equation equal to 0. So I'm going to subtract 224 from both sides, and I get 0 equals negative 16t squared plus 144t minus 224. All right, it appears if there is indeed a GCF, so I'm going to solve by factoring. So I'm going to take out a negative 16. When I take out negative 16, I am left with t squared minus 9t plus 14. That's equal to 0. Then I can factor. Factors of 14 that add up to negative 9. My negative 16's there. I still have a t. I'm going to have a negative 7 and a t minus 2. So the time in which that it is going to be at 224 feet would be 7 seconds, because I have to solve for it to equal 0, and 2 seconds. So it was at 224 feet, 2 seconds in and 7 seconds in. And after how many seconds will it be before the ball hits the ground? So we have to figure out when the height is equal to 0. It's on the ground. Equals our original equation, negative 16t squared plus 144t. Keep in mind, in this case, our height is 0, because the height was equal to negative 16t squared plus 144t. And there is a GCF, so I'm going to take out the negative 16t, and I'm left with a t minus 9 equals 0. So my two solutions are at 0 seconds and at 9 seconds. That is when it's on the ground. So it was in the air for a total of 9 seconds. All right. That is where we're going to cut off the notes for the video. The next couple problems really work about the same exact way. These are ones we're going to be working on during class before we have our assignment. So that's all we got. Have a good one.